In this tutorial, we are going to talk about the introduction to differential equations. Now let's start with some basic definitions. Now when you say a differential equation is an equation which involves one or more derivatives or differential of an unknown function. Now, a previous class in calculus, we saw that we can be given an equation in the form y squared equals maybe 6x squared plus x minus 4 for us to differentiate. So this is an equation, and when we differentiate it, we're going to get dy over dx equals 12x plus 1. So this is a normal equation, and maybe if I rewrite this nicely as dy over dx minus 12x equals 1, this becomes a differential equation because it has an unknown function, or it has a derivative of an unknown function. It contains a derivative. Here is the derivative, so this is different from this. So if we reverse this, we are going to get this back. So this is a differential equation. So in differential equations, we have derivatives or differentials of an unknown function. Alright. Now, when an equation involves one or more derivatives with respect to a particular variable, the variable is called independent variable, and a variable is called a dependent variable if a derivative of that variable occurs. Okay, what do I mean by this whole statement? When I have, let's say, dy over dx plus, let me use this, the squared y over dx squared plus omega squared y is equal to sine x. In this differential equation, where is the dependent variable and where is the independent variable? In this case, the y here becomes the what? Becomes the dependent variable. And the x here becomes the what? The independent variable. Because the idea is we differentiated the y with respect to x. So when I make the statement, the derivative of a with respect to b in the differential equations, the derivative of a with respect to b, what it means is I took the derivative of a with respect to b, another variable. So the a here becomes our what? Our dependent variable. The b becomes our independent variable. Here, the derivative is y with respect to x. So the y becomes our dependent variable, and the x becomes our independent variable. So that is that. What we take the derivative of is the dependent variable, and what we take the derivative to is the independent variable. Right, so let's consider another example too, another scenario. When I have partial derivative of b with respect to partial derivative of x, when I have a differential equation in this form, what do you think would be the dependent variable and the independent variable? Now, the dependent variable in this case is going to be the v, and the independent variables are going to be x and y, because here we took the partial derivative of v with respect to x, and here we took the partial derivative of v with respect to y. So we are differentiating v with respect to a certain variable or certain variables. So when we differentiated v, or the fact that we differentiated v makes v the dependent variable, and x and y, the fact that we differentiated with respect to them makes them the independent variable. So in this case, the v here is the dependent variable. This is the dependent, and the x and y here are the what? The independent variable. Independent variables. That is that for the dependent and independent variable of a differential equation. Now let's move on to the classifications of differential equations. Classifications of differential equations. Now, differential equations can be classified according to the type, the order, the degree, and the linearity. Let's talk about the type. Now, there are two types of differential equations. We have an ordinary differential equation, partial differential equation. So the two types of differential equations are the ordinary differential equations and the partial differential equations. Let's talk about the ordinary differential equation. We use DE for differential equations for simplicity's sake. Alright. When we talk about an ordinary differential equation, it is a differential equation which has only one independent variable and only ordinary derivatives are involved. It has only one independent variable. It has only one independent variable and ordinary derivatives alone. Example is dy over dx plus 2y is equal to 4. This is an ordinary differential equation because it has only one independent variable. And guess what the independent variable is? X here becomes our independent variable and y is the dependent variable. But we are focusing on the independent variable. So there is only one independent variable in this differential equation, which makes it an ordinary differential equation. And it has only ordinary derivative. Now the difference between the ordinary derivative and the partial derivative is that this is how the ordinary derivative is written. Y. We use the normal d. So the y over the x, this normal d makes this an ordinary differential. And when you see the del sign like this is what? A partial. So in the ordinary differential equations, you are going to encounter only the ordinary derivatives or the ordinary differentials like this, the d, not the del. So here we have the d, not the del, and we also have only one independent variable. So here, this is a what? An ordinary differential equation. Let's move on to the other one. That is a partial differential equation. Let me clean. So the partial equation is more or less like the opposites of the ordinary differential equation. Whilst the ordinary differential equations has only one independent variable, the partial differential equation has more than one dependent variable. One independent variable, and they also involve partial derivatives. So partial differential equations. These differential equations has more than one independent variable, more than one independent variable. And of course, they involve partial derivatives. So this is a partial differential equation. So if the dependent variable is a function of more than one independent variable, or in other words, if the differential equation has more than one independent variable, it's called a partial differential equation. And of course, it has only partial derivatives. For example is del u over del x squared plus del squared u over del y squared equals the function of x and y. So this is a partial differential equation because it has two independent variables in this case, independent variables, which is x and what? X and y. right? And it also involves partial derivatives only. That's the del, like I explained earlier on. The difference between the ordinary and the partial is that the ordinary uses the actual G of the alphabet, but then the partial uses the del, like a D with a curved tail. Yes. So this is a partial differential equation. Okay. Now we are done with the types of the differential equation. Let's move on to the order of a differential equation. The order of a differential equation. Now the order of a differential equation is the order of the highest derivative appearing in the differential equation. Alright, order. So the order of a differential equation is the order, the highest, is the order of the highest derivative appearing in the differential equation. What do I mean by order of the highest derivative? Let's take these two examples. One, d squared y over x squared plus x dy over dx minus y is equal to 3. Alright, now when we look at this differential equation, it is obvious that the highest order is what? D squared y over dx squared. So if the order of a differential equation is the order of the highest derivative appearing in a differential equation, then the highest derivative appearing, the highest order derivative appearing in this particular differential equation is the second order, which is d squared y over dx squared. So it makes this whole differential equation a second order differential equation. So this is a second order differential equation. Let's take this example too. Y over dx plus 2y is equal to 4. So the highest order appearing in this differential equation is the first order, which is dy over dx. Therefore, this whole differential equation is a first order differential equation. So the order of the differential equation is simply the order of the highest derivative appearing in the differential equation. So if we have the squared, the cube y over the x cubed minus the squared y over the x cubed plus 4 is equal to 0. The order is going to be third order because the highest order is what? The third order in the differential equation. So that's what we mean by order of the differential equation. Right, so we are done with the type, we are done with the order. Let's move on to the degree of a differential equation. It's quite simple. All you need to do is pay maximum attention. When you understand the basics like this, differential equation is not going to be a threat to your life. Alright, let's move on to the degree. So the degree of a differential equation is defined as the power to which the highest order derivative is raised. So the degree of a differential equation is defined as the power. So the power which the highest derivative is raised. So when a differential equation, when you see a differential equation, the power or the exponent of the highest order, the exponent or the power of the highest order derivative in that particular differential equation is the degree of the differential equation. When we have d squared y over s squared plus omega squared y is equal to sine x. When you're asked to find the degree of this differential equation, what you have to do first is to locate the highest order derivative. So in this particular differential equation, the highest order derivative is the squared y over the s squared. That's the second order. So then I look at the power. This is raised to power 1 because it is standing alone. So that means this is a what? It's a first degree, or it is a degree 1 differential equation. So it's a first degree differential equation, or a differential equation has a degree of 1. Alright, let's take this example too. We have, let's say, dy over dx all squared plus 4y is equal to cos x. Determine whether this the first or second order differential the degree of the differential equation is first or second. Like I said earlier on, what you have to take note here is that you first of all have to identify the highest order derivative in the differential equation. In this case, the highest order derivative is y over the x. And what is the power of the highest order derivative? It's raised to the second power. So it makes the degree of this whole differential equation the second degree. Now we should take note of this. The squared y over the x squared is not the same as the y over the x all squared. This is never the same as this. This means the second derivative of a certain function y with respect to a certain function x, and this the square of the first derivative of y with respect to x. So they are two different things altogether. So don't confuse yourself. Let's take the last example under the degree of a differential equation and move to the linearity. The squared y over the x squared plus dy over the x all squared plus 4y is equal to sine x. What is the degree of this differential equation? So what we always do is we identify the highest order derivative in the differential equation. And here I know that my highest order derivative is the squared y over the x squared. Although I have the y over the x here, but the squared y over the x squared has a higher order than the y over the x. So if this is my highest order derivative, then what is its power? It's obvious that it's raised to the first power. So this becomes what? A differential equation of what? First degree, or a first degree differential equation. So don't be confused. Don't say that but we have dy over the x here, which is also raised to the second power. No, it doesn't matter. Here we are focusing on the highest order derivative, which in this case is the squared y over the x squared, and it is raised to the first power, which makes this whole differential equation the first degree differential equation. Alright, let's move on to the last aspect. That's the linearity. When do we say a differential equation is linear? So linearity of a differential equation. Now, a differential equation is said to be linear if only if a these are the conditions. 1, the degree of the highest derivative should be 1. So the degree of the highest derivative must be 1. It's a must. Must be 1. B, or the second condition, is that a dependent variable does not multiply its derivative, or a dependent variable must not multiply its derivative. Dependent variable must not multiply its derivative. So let's look at examples which involves the linearity aspect of the differential equation. Let's consider this differential equation: s cubed y over s cubed plus 5x y over x plus 6y is equal to u to the power of x. Is this differential equation linear or nonlinear? Now let me look at my first condition. The degree of the highest derivative must be 1. Let me check the degree of the highest derivative. So in this case, the highest derivative is the cubed y over the s cubed. So the power is indeed 1. Okay, so my first condition is satisfied. Let me see if a dependent variable has multiplied this derivative. Here, the dependent variable is what? Y. Do we have any y multiplying the derivative? Here, it is x which is multiplying the derivative. No, there's no such thing here. That means this is a linear differential equation, right? Because it satisfies the two at it satisfies the condition, the degree of the highest derivative, which in this case is this is 1, and we do not have any dependent variable multiplying its derivative. So yes, it's okay to see that this is a linear differential equation. Now the last example is the squared y over s squared plus y dy over x plus 2y is equal to x. Pause the video and try. Is this a linear or a non-linear differential equation? The first condition is that the degree of the highest derivative must be 1. Let's check. In this differential equation, the degree or the highest derivative here is the squared y over the s squared. And yes, it is having a degree of 1. It is raised to the first power, so it is true. That satisfies the first condition. The second condition is that a dependent variable must not multiply its derivative. Let's see if that one too is satisfied. If so, then we can conclude that this is linear. So with the first one being satisfied, let's check the second one. Here in this differential equation, the dependent variable is y and the independent is x. So do we have any y multiplying the derivative? Yes, we have y multiplying the derivative. So this term here, this term y dy over dx makes this differential equation linear. So that is the idea of the linearity of a differential equation. The degree of the highest derivative must be 1, and a dependent variable must not multiply its derivative. Thank you for watching the video, and stay tuned for the next episode of differential equation.